This project is for Engineering 122 at Louisiana Tech University. The project was worked on by Noah, Dalton, and David. The goal of our project was to detect gases in the air to help detect a fire before it starts by sensing for gases such as methane, carbon monoxide, and LPGs, also known as combustible gases. And to lower the rate of asphyxiation to these gases. Another objective that we had was to also be able to tell you exactly how much of these gases there are in the surrounding area around the device, and to also make the device readily available for not only commercial but also private use.
So next we'll go into a little bit more about the actual sensors and devices we used for this machine. As you can see, we have the deconstructed machine, and this is actually the main sensor. This is the MQ9 gas sensor, and this has a digital and an analog output pen. We decided to use analog because we can get much more data from it, and instead of just seeing if it's there or not, we can see actually the exact amounts from the analog output. So the way it works is that it actually has a tin dioxide layer right over it, and when heated up for 1 to 2 days, it attracts oxygen, and this increases the resistance. And when in the presence of carbon monoxide, flammable gas, and methane, it will actually disperse the oxygen. And through this, the resistance will go back down, and through measuring the resistance, we can actually see the exact amount of gas that's in it, with a provided graph that we can see for each of the different gases. There's one main problem with this though, and it's that the Raspberry Pi actually doesn't have an analog input. So we had to use two MCP 3008 digital to analog converters, and basically what these do is they take the analog output that the MQ9 is giving, and they use 4 pins that actually turn that into a lot of digital inputs that the Raspberry Pi can actually understand.